Hi students, coming to the next application of dynamic programming, that is the all pairs shortest path. So in the previous video I had explained about the chain matrix multiplication. Now let us see the all pairs shortest path. So what is here? The name itself is saying that all pairs. So we have to consider all the pairs that are present in the whatever the graph we have taken. So by visiting all the pairs, all the vertices, we have to find the shortest path by using the dynamic programming approach. So in all pair shortest path problem, we have to find the shortest path. Here we have to find the shortest path between every pair of vertices. So whatever the vertices that are present in the graph, every pair of vertices in a directed graph. So one thing is here it is a directed graph. So a graph we have to take, that graph should be a directed graph. In that graph we have to find the shortest path between every pair of vertices. So the all pairs shortest path problem is to determine a matrix A. So let us take the matrix A such that A of I comma j, that is the ith row and the jth column, A of I comma j is the length of shortest path from I to j. So we have to take a matrix, that is a matrix A. So a matrix A consisting of some paths from one vertex to another. So finally we have to find out the A of I comma j length. So which indicates the length of shortest path from I to j. So in between I to j there are different nodes are present. Okay. So suppose different nodes are present. So finally we have to find out a path from I to j, that is the length of the shortest path we have to find from I to j by visiting all the vertices. So let us take A of k I comma j represent the length of shortest path. Let us assume that ak I comma j represent the length of shortest path from I to j going through no vertex. So sorry, going to number of no vertex of index greater than k. So that should be, you have to be remembered. So whatever you are visiting from I to j, you are visiting some nodes. So you have to consider that no vertex of index greater than k. So those vertex you have to be visited. Then the formula we obtained to find the shortest path of length of shortest path for the array of matrix is ak I comma j is equal to minimum 1 less than or equal to k less than or equal to n a power k minus 1 into I comma k plus a power k minus 1 of k comma j comma c of I comma j. So this is the formula to find out the all pair shortest path problem, a path that is visiting from I to j. So by using this problem we can find out the all pairs of shortest path by visiting all the vertices in the graph. So let me show you the algorithm for this all pair shortest path algorithm. So before going to know the example, with the help of this algorithm we will solve the example. So algorithm all pairs, here we have taken the attributes as cost a comma n. So here the cost 1 to n between means it's a cost of I and j. Let us take a cost of 1:n. 1:n is a cost adjacent matrices of a graph which having n vertices. A of ij is the cost of shortest path from vertex I to vertex j. So this A of I comma j is the shortest path from I to j, and cost of I comma j is 0 for this condition, 1 less than or equal to I less than or equal to n. So that you have to be find out. Not cost of I comma I means between if suppose only one vertex is there, the cost of visiting this vertex is only the cost is 0. Cost is 0 if you take only one vertex. Now let us check. For I is equal to 1 to n, then you have to find out for j is equal to 1 to n2, then the cost of A of I comma j is equal to cost of ij. So just copy whatever the cost that is there to visit from I to j, that cost is moved to A of I comma j. Then you check for k is equal to 1 to n2, again I is equal to 1 to n2, for j is equal to 1 to n2, the formula for calculating the shortest path, that is A of ij, is equal to minimum of A of ij, comma ik plus A of kj. So this loop is continue until it reaches the n. So this is the algorithm for all paired shortest path. Okay. Now in the next video I'll explain all paired shortest path by taking example. Thank you.